Thank you. It will say that the hardware engineers will say that it is a software problem, and the software engineers will say it is a hardware problem. Okay, that is a standard joke that has been going on for 40 years since I was working in this field. And then, as I just said, in 1971, Intel invented electronic devices that you can put a software inside it or instructions inside it, and then it changes the entire electronics field. And no longer we can simply just develop a device that can only have only one single instruction. For example, the light over there, there's only one instruction built in. So it actually has software in it. So, but that instruction, there's only one. And the instruction is when you turn on the light switch, the light will come on. And then when you turn it off, the light switch, and then the light will go off. That means there's only one instruction built in that is on and off. That means you can only teach that particular light to do only one thing, to turn it on and off. And then another example will be the heater. Okay, so if we turn on the heater will come on, and then it will keep you warm. If you turn it off, and then it will turn off the heater, and then you were going to be cool. Okay, so that is actually what the electronics or electrical devices are before 1971. But in 1971, a company called Intel says, why don't we teach us manufacture an electronic device that can do more than one instructions? An example will be what? Will be a light. So we can put some instructions, more than one, and we call those software if it is more than one instructions. And then now when we turn off the light, it will do something, say, okay, in 5 minutes, and then when you see more people come in, it will automatically turn it off so that we can start our presentation. Okay? And then now, what happened when it reaches 12 o'clock, everybody has to what? Has to go and eat. Then automatically turn it on so everybody know what? It's time to go to eat, rather than listening to me. Okay? And then it's even, you have some of these at home, that for example, you can automatically have instructions that run all the time. Then when it's light, when it's dark, it will turn on automatically. And then when it is in the morning, when you see there's a lot of sunlight, it's going to turn it off. In that case, they will save you what? Electricity. And so it's an electrical heater. Right now, you don't have to turn the heater on or off because you have what we call a thermostat, a Honeywell thermostat. That means it automatically have instructions, which is always executing, always running. And then when the heat is on, and then when there's a lot of heat in the room, when the temperature is high, it's automatically we turn the heater off. And then when the heat is low, that means it's cool in the room, it's automatically turn the heater on. Exactly. So we don't what? So what a computer does is that a computer now, today, actually works just like a human. That's why we need a computer. Okay? Because we always want somebody to talk to us. We always want somebody to work for us. And then we always want somebody to work with us as a team. And that's why we are here. We need hardware and software. A hardware make a machine work, for example, to send out light or send out heat. A software make it intelligence so that it can work just like a human. So that there's always a human, just like a human, that's always controlling the light without we actually have to worry about doing it ourselves. Okay? So, all right. So that's more or less a kind of introduction, and then that's me, and then I'm going to talk about what is why we want the web, and what exactly is cloud computing, and then most people has heard of the web and use it, and then we will talk about the cloud computing, which is actually a term which just come out in the last few years. Okay, so let's see what is this about. Okay. And then, first of all, I'm going to show you a slide of what curriculum that we are going to offer. That means we try to offer you a curriculum and courses that after you're taking some of these or all of these, that you have enough skill to go out and then develop applications or devices which is used in the web and also in the cloud industry. Okay, so now I'm going to quickly, I'm going to show you that we have 3 degrees in the web development. And then the first one is what we call the certificate of competence. And that is only 15 credits for 1 quarter. Okay. Now the 15 credits means you're going to take 3 classes. And then that is the normal load for 1 quarter. Okay, 15 credits is the normal load. Now, we were going to take 3 quarters, then you end up with a web developer certificate, and that is the one that will, you're going to take the first 6 courses. The first 3 courses, 241, 242, and 243, is good enough for the certificate of completion, and that is for 1 quarter. And then if you take 3 more classes, 244, 245, and 246, these are, of course, these are core courses that were good enough for you to satisfy the core requirement for the developer certificate. And then that is for 1 year, of course, you have to take some other classes, supplementary classes like mathematics or some other computer science classes. And then if you want to go further, take 251, 250, and 260, and these are mostly on a database and cloud computing. That would take another year, and then you will have a 2-year associate technical arts degree. All right. Now this is a general picture of what the curriculum will offer, and then I will go back to this picture after, and then go into this in more detail. And after I want to show you the next is what is cloud computing and what is the web. All right. So I'm going to go back to the future, give you a general introduction to the web, and of course or to the internet, but that is from the perspective of a web developer. All right. Okay. All right. So here, this is what it is in 1977. This is the beginning of the internet. And at that time, it's called the ARPANET. And I believe this is a network of connecting computers together. And these computers, most of them are computers in our military bases in the world. Okay? And about 50 years ago, in 1960s, our government have a concern that we need a system to connect, or communication system to connect all our computers in our military bases. And then you can see that many of those, for example, some of those are in Hawaii, and of course the major one is in Pentagon. And of course you see all these rectangle are computers that are running in those military bases. Now in 1940s, during the Second World War, we are the first country to develop digital computers. And then of course 20 years later, in the 1960s, of course, there are many computers that are running together. And then, of course, we want them to send information to each other. And that's why in the 1960s, the government, under President Kennedy, ordered the development of this network called the ARPANET. And then now notice that here, each rectangle is a computer which is connected to the internet. If you count them, of course, there's about 100. And of course, today, do you know how many computers or mobile devices are connected to the internet? How many? Many. Now many. Now let me tell you, today the number of nodes. Now each of those computers is a node. A node is defined as any devices which can send information to the internet as well as receiving information. By that definition, my cell phone is a node, and also your desktop is a node, and a laptop is a node, iPad is a node. Okay, at that time you can see there are about 100. Today, let me tell you how many are there. About 5 years ago, the number of connected devices to the internet exceed the population of the world. Okay, so without citing a figure, then they will probably let you know how many of those. But that is the beginning, and then now here. Now the reason I show you this is not to talk about the infrastructure, because the other instructors already have. Now the idea of the network is this. Very quickly, is that suppose I want to send a message from the Pentagon to Hawaii. Okay, without this network, I have to send it. I have to call it using a modem telephone and call it from Hawaii and from Pentagon. But using this network, I have a lot more options. Why? I can simply just send this to this node, and this node to Rogers, and here, and here, and here, and here, and here, and here, that will reach Hawaii. Or I can send the message and here and here. By the way, the message is called an email, electronic mail, okay? Anything that can send using electronics. I can send it from here to here, and then I can reach Hawaii, or I can send it from here to here to here. I can also send it to Hawaii. The idea, if somebody, if there's a malfunction in this network, or this phone line, or enemy destroy this phone line, I can always find a path or a way to connect electronically or call Hawaii from Pentagon. That is the idea. Okay, and you can see here that the more computers we have, the easier it is to find a path. And today, because we have billions of computers, that's always impossible that we cannot send a message from one computer to another computer. The more computers that are connected to the internet, the more efficient it is. The more efficient being defined is it will quickly find a path from one computer or from one cell phone to another cell phone or from one iPad to another iPad. Okay. So right now we have billions of those, and then it was so that's always impossible for you not to send a message, not to receive a message when somebody sends an email to you, and vice versa. Okay, and that's the whole idea of the ARPANET. Good. Anyone has a question so far? Okay. Now it takes years to understand this. Okay, if you have a question, let me know. The most important why we have this network. Now many years ago, before 1977, we can send the information from Pentagon to Hawaii, but then we have to make a phone call, and then if that phone line is down, then there's no way to make a phone call. But today we can send it from many to another computers, because we are all interconnected. There's so many computers in this network, and just like a spider web, and that's why we call the internet today the web, because we're interrelated with so many people. So if I want to send a message to you, I can tell you, you can tell him, you can tell him to tell him. Or I can tell you, you can tell him, you can tell him to tell him. Because I know so many people, there's no way that I cannot send an email to anyone. And that is the idea of the ARPANET. And that is the idea of the internet. Okay, and where does the internet come from? So, and then it's very ironic. So what is the internet? And today, it is the internet where we have, as I said, there are billions of connections rather than just 100. So you can see the whole world is connected. All right? And then quickly, what happened to the ARPANET? Now, why does it become the internet? And then in 1977, there's one major or very significant invention or development in the field of computer science and mathematics. That is, we find a way so that we can send information from one node or one computer to another computer. But we find a way so that we can hide those information. And the technical term is called encryption. We can encrypt the data so that even if we can send it from Pentagon to Hawaii, that if anyone intercepts the information, nobody can know what it is. And that process is called encryption. Now we have encryption for thousands of years, and then you can say Julius Caesar also used encryption. During the Second World War, he also used encryption. The Japanese used encryption, etc. We're able to win the war because we can break the Japanese encryption, etc. But in 1977, some professors at MIT and Stanford developed an encryption technique that is not breakable. A magnificent invention. Because as engineers, I was taught in engineer school that nothing in the world is unbreakable. There's nothing in the world that can work 100%. Now this technology, encryption technology, is called asymmetric encryption. And then at least theoretically, it is unbreakable. That means it works 100%. And at least we have something in the world that works 100%, okay, so. All right. And then because of this, because it's so reliable, that nowadays today, everybody can do online shopping. We can send a credit card information, and then we can also send a file income tax return. We are not afraid of anyone who can intercept our message because they cannot decrypt it. Okay, and that happened in 1977. Ironically, incidentally, it's the same year this picture picture was taken. Okay, and ever since now we can send information over the network without fear of anyone intercepting it. So there's no reason to have this system classified. That means we no longer need to hide those. Okay, so and for that, and then the government decided to open it up. That means declassified it. So in the 1980s, whatever, and then the whole internet is free, open to the public. And anyone with a computer can join the internet. That means you can connect them as long as you pay your ISP, connect to the internet. And that is the reason why today we have so many computers out there. That means that we have more billions of computers that are connected to the internet. All right. And that is why we have the internet today and why we like the internet. Well, I haven't told you why we like the internet yet. So let me go to the next layer, next slide. Now look at this next slide. What do you see in this slide? Okay, you will see. What is he doing? He's doing what I'm doing. He's smiling, and then he's also smiling, and he's smiling. And so we have 4 smiling faces here. 1, 2, 3, and 4. So the internet, why do we have internet today? Why do people want the internet today? Because it makes you happy. That's why. And that's why you're here, and that's why I'm here. Try to make everybody happy. That's why I like to be an instructor of the web here at the Edmonds Computer College, and it's true. And then let's look at why they're happy, okay? And then we look at that, like why is he happy? Because now he's talking to his, I suppose her boyfriend. They're talking to her boyfriend. That's why her boyfriend is also happy. So that's why now we can call somebody, and then not only locally but internationally without worry about paying long distance, because we can use what? VoIP. That is what we call the application. That means we can use the computer and also the internet for some kind of a purpose, and that is called the application. That means we can use the computer together with some software called Skype or whatever, and we can talk to somebody. Locally we can talk to somebody, but we can look at them. And then that is the type of tools or applications we need to learn to develop, and that's what our program is about. Good? All right, good. And then that's why we have this program. And then let's go back to the previous. And now we have all these programs and all these courses, because they will, after they're taking them, you should be able to develop those programs called Skype, etc. They make everybody happy. Yeah, good. All right, so anyone has any questions so far? Okay, so all right. Now I want to tell you this. Okay, so you're looking at her being happy and him being happy. But look at the computer. The computer is always happy. Why is the computer happy? The computer is just a machine. Is the computer today smart enough to become happy? Well, I told you that software make a computer intelligent, but can software make a computer happy? And so he's happy. Then why is he so happy? What's that? Maintain. Okay. Anyone? Any idea? Users happy. Okay. Very good. All right. Now I tell you what is happy, because look at this. Now what do you think she is doing? Well, notice she is doing online shopping. See Amazon. See Amazon started by selling books, and of course today it sells almost everything, anything under the sun. It's also selling you clothes. So now she's doing shopping. She's buying new clothes. So she is happy. Then why is the computer happy? Well, Amazon is happy. Amazon is making a lot of money. Amazon today is the #1 retailer in the world, actually better than Walmart. So the computer is happy. So if you're a company, of course, you want to be this computer to be happy. So everybody wants to sell the things online now, including Walmart. Okay, so and now, of course, everybody is happy. So what do we, like as a IT people, and also IT engineers, what do? Well, we need to make them happy or even happier. And then we need to develop those applications or software that runs in these computers. And those software that runs in those computers that powering like Amazon or Skype or whatever, what do we call them? We call them a server. Right? And of course, we are the client, okay? She is the client, and then tonight when you go home or during the break, you will pull out your cell phone and then whatever, and you are the client because you are talking to the server. So what is a server, by the way? Okay, so I'll give it, now these are all servers. Yahoo, eBay, Amazon, Google, MSN, they're all servers. So what is a server? Now I'm going to give you my definition of a server. Okay? Now a server is someone who never sleep. That is a server. Someone who can provide you with a service, do something for you, but they never sleep. Okay? Then let me ask you this. You go to see a doctor provides you with service. Of course, the doctor provides you with medical service. He gives you medication to take care of you medically. But is a doctor a server, according to the definition I just told you? No. Because if you call him 2 o'clock in the morning, call your doctor, what will happen? Okay? You're dead? You're dead? You said you're dead? Okay, all right. Then if you call them on Sunday, what will happen? Well, she's probably paying. By that definition, a doctor provides you with service, but it's not a doctor. But it's a hospital, a server. Emergency room, yeah, they open 24/7. That is a server. So the server, in order to qualify the server, you need 2 things. Number 1, a server must provide you with some kind of meaningful service, like a lawyer. Okay, they provide you with legal service, and also a school. School provide you with what? Education. But then we are not server because I'm not here 2 o'clock in the morning. All right, so, and then somebody say, why don't we make a school that can run 24/7? Why don't we make a hospital that can run 24/7? Or why don't we make Walmart that run 24/7? Somebody say, it's possible, okay? Can we make a Walmart running 24/7? Yeah, that's possible because we have something called a server. Because a server is a program, it's a computer that works 24/7. Like I told you, there's one thing the computer can do for you that the human can never do. Because computer can work around the clock without complaining. No human can do that, right? So once you turn on the computer, like an autopilot in the aircraft, it will continue running the aircraft without stopping until, of course, the fuel ran out. So a server is just a online shopping mall, but then, of course, it runs using software. As I told you, a software is simply just a sequence of instructions that make it just work just like a human. Okay, and then those dumb machines, before we have computers, only have one instruction. That means it can turn it off when we turn on and off the switch. But one instruction is not enough. Now, this has a lot of instruction built in. That means when you go to Amazon, you can simply just click on a button, and then it will select a merchandise, or you can search for merchandise, and after that, you can fill in your information after you decide to buy it. So there are a lot of instructions that the only human can carry out a long time ago. But then using software, we can simply just teach it how to do that. We simply just program it, or just simply just store those instructions step by step into the computers, which we call the server. Okay, so, all right, good. All right, and then being a web developer, we essentially are developing those software inside the web server. So we were working for Amazon.com, we were working for CNN.com, or you may as well work for us because we also have a website. And the thing is that we are like Amazon, they will provide you with retailing or the services, but they do it 24/7. It's good. Right. Another example is before we have this internet, fine. Now every time I need money, I can call my dad. But then of course my dad can go to sleep, okay? And I can call him at 2 o'clock in the morning, or my dad can refuse to pick up the phone, and then I ask for money. But now we can do what? We can simply go to Bank of America and simply just log in and then get some money from them, assuming that you have good credit. Okay, so. And that is what? Like your dad serving as your financial provider, but it does it 24/7. And that is what a server is. And a web server is something that operates using the internet, because we call the internet the web. All right, so good. All right, anyone has any questions so far? Okay, so, because I'm now going into the cloud. So you have a question about the web? Ask it now before I go to the cloud. Very good. Yes.
I was looking at the list, like JavaScript
yeah.
and stuff like that. They seem to be client-side scripting.
Yeah.
Which one of those would be like server-side? Is
Yeah, essentially that will be PHP, but then I will show you the couple of slides ahead, and then we will go back and tell you, go back into each individual degree and courses and tell you which one is client side, which one is server side, and there's something in the ahead. After I told you, after I finish telling you what a cloud is, and then we will go back into the curriculum, and then that will be the end of the of me. That means end of the presentation today. Okay, is okay? All right, then quickly go into the cloud. What is the cloud? All right, okay. All right, so the cloud is very simple. Okay, somebody found out that a few years ago that if you have 10 of these web server, if you put them together, okay, and then if you bundle it together, the technical term is cluster. That means you connect them electronically, also with software. Then suppose you put 100 of those together, they will work much more efficient, much more powerful than you have 10 of those working individually, right? So you have 100 you working in a team, you will produce much more, and then you will be much more productive than just one single individual working individually without any communications. And that is the idea. So we always work in a team. We always work as a society because we can work together. Okay, so very few people work alone. Not even Bill Gates. Even Bill Gates as a partner when he started Microsoft. And who is he? Who is Bill Gates' partner when he started Microsoft? Microsoft was started by two people, Bill Gates and whom? Paul Allen, the owner of Seahawks. You should know that, the owner of the Seahawks. Without Paul Allen, we probably lose our football team like the Supersonics, because we have Paul Allen, who, of course, the co-owner of Microsoft. So that is the idea of the cloud. The people say that, of course, before the cloud, we have, like CNN has one, like a company A has their own web browsers, most likely inside its own company. And the company B will have its own web browsers. And the company C will have their own web server. So we'll have 100 companies which they will have 100 web server. That is just a PC running individually inside each of those companies. But then somebody say, why don't those 100 companies, of course we have 10 or thousands or millions of websites. So people say, why don't we just put all those web servers from those 100 different companies all together in one single room and connect them together. And then together they will also serve those 100 individual companies. And in this case, since they work together inside just one single room, and then they will have much more powerful than those web servers working individually in separate buildings. And that is the idea of the cloud. So if we say the whole is stronger or bigger than the sum of its parts, that is exactly what the cloud theory is. The whole is bigger than the sum of its parts. Never heard of that? Okay, all right, so that is it. That is the cloud. That's why we have the cloud. And then now, so of course, when you have to put a lot of computer servers, web servers together, a lot of PCs together, you need a big company. And of course, those big companies will be like what? Google, and of course, Microsoft. But surprisingly, the largest, those companies which provide a lot of those computers that people can use, of course, you have to remotely either connect to it using a FTP, whatever, but it's pretty easy to be done. So they have companies, we have millions of these web servers. They are all inside one single building. And then if you want to use them, you simply just pay them, sign in, and then register and pay them. Of course, they charge you by the minute. Yeah, just like renting a car. Renting a car charge you by the day, and these charge you by the minute. Why by the minute? Well, you can, if you don't need it, you can turn it off. Okay, so they won't keep on charging it. And that is one reason that people using the cloud, because you pay as you go. Just like that would be wonderful if every time I don't make a phone call and then I can turn it off and then they don't charge me. But no, but they charge you by the what? By the month. Okay? And the cloud actually charges you by the minute. So if you don't need your web server service, simply just turn it off and then they won't charge you. And that is one of the reasons that people would like, or the consumers like the cloud. So now, okay, so all right. So now the big companies will be, but you need the big companies because the more web server you put together, and then the more efficient the system, that means you can charge your customer less. So now just like car rental companies, we only have 3 or 4, like what? The Hertz or Avis, whatever. So the biggest one is Microsoft, and then we can see Office. As a matter of fact, and of course Apple, iCloud. So all your information, all your apps are stored in the cloud with a lot of computers, and also Google. But these are companies are called a cloud service provider, CSP. Just like when you go home, you of course have to pay your ISP monthly fee in order to get yourself online. That like Comcast, whatever, and the like a Quest, CenturyLink, and those are called an ISP. And ISP stands for what? Internet Service Provider, and these are called Cloud Service Provider, CSP. And of course, Microsoft is the second or third largest one, so is Google. I think Microsoft is number 2, Google is number 3, whatever. But who is number 1? The number 1 is right here in our backyard. Amazon. Surprisingly, Amazon is number 1. And it's not surprising because they of course, started their business as a website. Okay, today it still is. So Amazon, here it is number 1. And that is one of the reasons I'm here, as a matter of fact, because I know this city has 2 of the largest cloud service providers, Amazon and Microsoft. And then for those of you who are looking for jobs, of course, including myself, of course, and this is an excellent city because those 2 companies, the 1 and 2, Amazon and Microsoft, are right here. Of course, if they're headquartered here, they tend to hire technical people who are here. All right, so, okay, all right, so, all right, okay. And, okay, so this is the cloud computing. And so we start off with what the internet is. The internet started out by sending, allowing military bases to send information to each other. But after he has declassified, of course, many people joined it, including consumers like us. And the companies like Google, Yahoo, Amazon, Walmart, whatever, they find a way to use it because people can go there and do online shopping, whatever, 24/7. All right, so, okay. All right, so right now, now of course, this is Microsoft Azure, which is the cloud service. And then, of course, this is the Microsoft Amazon Web Service. As I told you, this is 1 and 2 in the country and also in the world. Okay, and then in order to work the general websites, today most of the websites, of course, web server are hosted in the cloud. And that's why when we talk about the web, we have to talk about the cloud. Because the cloud is now and in the future, everybody, rather than hosting, putting the web server individually inside the company, they will simply just use the cloud, simply just go to this website and then sign up for an account. And now you can put all your web pages into the cloud server. Okay? And it's just like everybody is renting a car, assuming that a car is cheaper than buying a car. But it may not be. Renting a car may not be cheaper than buying a car, but then in web server, it's much cheaper. And in the future, it's getting much, much cheaper as more and more people are using those cloud service providers. And that will be it. And that is the why we have the cloud, we have the why internet, why we have the web and the cloud. And then the rest of the presentation, as the gentleman is asking, then I will go back to our curriculum, and then I will go there, and then I will go degree by degree, and I tell you what courses we have to offer that let you capable of working for those high-tech company, including the cloud service provider. Okay, so now the first degree we have is what we call the COC. Now COC for the web development as well as other department like internet or security is usually 3 courses or 15 credits. And then you can, so the first one is a CIS 241. It is in sequence. Let me just go to the next slide and tell you what you will learn and what you can do after taking a CIS 241. Now, all the information that is sent back to you, whether you go to CNN or Google, whatever, come back in a web page. What is a web page? Web page is just information because you go to a website, go to the internet looking for information. But a web page are information they put together, formatted together, or typesetting together. They look like a magazine. It's multicolored, okay? It's multi-font, so with pictures, and also so that you just like you're looking at a magazine you purchase at a newsstand. So now that is one of the reasons people go to the internet. They no longer have to go down to the library or go down to the newsstand to buy the magazine or newspaper. They can simply just go and then look up. And then that was not the case in here, because in 1977 they have not developed the technique to display those information just like a newspaper. You only read them just like a notepad. And for some people, that may not be as interesting. So here, that is what we do in CIS 241, and this is one of the sample projects. So by the end of the quarter, you should be able to develop this website together with link. That means you click on this button, you will go to another website, and also with pictures, and also with video. Yeah, you can put your iPhone videos and pictures in that website, okay? Just like Facebook. That's why so many people want to go to Facebook. I mean, yesterday they break the record. I believe they said 1 billion people logged into Facebook yesterday. Why? Because they want to see this. They want to see the video, pictures of the fans and relatives or the loved ones. So okay, this is the very first we offer, and then now after taking that first courses, you're able to do this. Good? Anyone has any question? Okay, now let me go further, okay? So what is, of course, this degree, which is only 1 quarter, 3 classes, but what is CIS 242? And okay, CIS 42 is teach you how to make a computer like Bill Gates. Now, Bill Gates is a mathematical genius. That means we can teach the computer how to make a calculator. So that means it takes a lot of geniuses to be able to be a mathematician. So here we can show you how to make any websites, whatever, and to become just like a mathematical genius. That means we want to teach you how to make a computer even smarter. Not only simply turn off and off the light when it was at 12 o'clock, or when it is light, or when it's dark, whatever, or turn on the heat when it is cool or hot. We can do even more smarter because it can do those fancy mathematics. So you become an engineer, whatever. So the computer become an engineer. Okay, so right. That means we make them almost as smart as a human. In order to do that, we need to learn a language called JavaScript, which is what the software is written inside the computer applications. Okay, so we need to do what we call some kind of programming. That means learn how to write those instructions, which the computer will do when somebody hit a key or ask it to do some kind of calculations. Okay, and that means we make. Another term is make a program, a website dynamic. Just like me, I can sing and dance dynamic. It has to be have a lot of instructions to build in, and then to make it a dynamic, whatever. So that is the second course. So if you look at the first course, 241, essentially all these are just picture and also messages. So that's what we call static. Essentially, you are using a website just like reading a newspaper. But that's good enough for people to go to the web. We can go to CNN, Times Magazine, or Seattle Times. We no longer need to buy a newspaper. But then people want more. People say, I want to use the computer to become an autopilot, to fly the aircraft. And then you need to teach it to do math. Okay, so math is not that difficult at all. Even a computer can learn it. Okay, but then you need some kind of language called JavaScript. And then now 233 is called a PHP. Now this is let me just quickly go back to the now CIS 241 teach you how to put information, but those are static information. You can look at beautiful pictures, beautiful text with different colors of font, okay? And then 242 is make it even more, the websites even more dynamic. That means it can have more the intelligence, so you can use it to what? to do Facebook. Okay, that means online banking because it can talk to you, interact with you. Okay, so, and then now what is a 243, which is the last course in that degree? Okay, we're going to teach you PHP, but what is that? Okay, now okay, so let me just go to that. Now 243 is something like this. Okay, now here let's say this is what I'm showing here is actually a game. Now this is called a poker dice game. That means you what? You just simply click the button, and then if it show up to be a 2 of a pair, or a full house, or 3 of a kind, you win some kind of money. Or just like playing poker in Las Vegas, whatever. Right, okay. Now you can do that if you know everything about 241 and 242. Because 241 allows you to put out those beautiful pictures, like the dice, whatever. And then 242, of course, you can interact with you. So you can what? You can, of course, you can do mathematics, so that the computer can also calculate the odds that you are going to win, etc. Also be dynamic enough to display all those different dices, different values every time you click on the button to play the game. And then why do we need 243? The reason is very simple. In order to make somebody smart, you have to think like me. So that's called instructions. A lot of instructions programmed here. But at the same time, the intelligence has 2 components. First of all, the way to think, that is called instructions. The second, you have to remember things, okay? So you have to keep a memory. So if I can't remember what happened yesterday, what happened today? Because I won't be able to come here because I don't remember that I have to come here today. So the intelligence actually of a human as well as a computer has 2 parts. First of all, a ability to think like a calculator. The second is it has to remember, capability to remember things. Okay, so now, like these games, let's say suppose I roll the dice and then I win $10. Of course, the computer has to remember that I win $10. And now my bank is, I start out with $100, so when I click on this, let's say I have a 2, 3, 4, 5, 6. Actually, I have what? I have a streak, so I win $10. So now that means when I click this, my cash will go up to $110. Of course, I wanted that to be remembered by my computer because I won $10, okay? And then how does a computer remember you? Okay, well, you go back to this picture here. Now, how does Amazon remember you? Suppose you're Amazon how does Amazon remember you? Well, they will simply just take all your information that you entered, and then in the web server, they have a memory. How does a computer remember you? Well, I know how we remember. I'm not a doctor. I think it all happens in here for the human. Okay, for the web server, everything is stored in what we call a hard drive. Okay, so that means inside, whenever you buy things, whatever, and then your computer will send the information through the cloud and then to your web server at Amazon. And Amazon, after processing your order, meaning calculate your total prices, etc., and then it will keep those information in the memory and in the hard drive. So, and then why do they want to do that? Because they want to forward the order to the shipping department. And the shipping department can look at the memory and see what you have bought, and they will gather all those merchandise and send it to you. Right? So in order for the web server to work, and then you have to have some kind of a program, and the program is written in 242 in JavaScript. But that's not enough because we still need it to store the information in the computer server hard drive, and we need those programs to run inside the server. That means now PHP is the language that we use to put in the instructions so that it will run in the server. So when somebody go and then purchase something, and then our JavaScript program, which is running in the client computer, and that was actually running inside your web browser. So if you are using Internet Explorer, that will be a JavaScript running inside your Internet Explorer or Firefox, and then the JavaScript will gather what you type in. So I type in three books and then 4 of these dresses. the JavaScript inside your computer will run a program that will send that information to the web server, which is Amazon. Okay, and that was you would learn all these in 241 and 242, and then 243 is what happened inside the web server. So inside the Amazon, they have program software written in PHP. All right. That was the contents of this 243. Okay, and then it will keep. Then when you run those programs written in PHP, it will process the order, store them in the memory, in the hard drive, so that it will always remember you have purchased something. And the next thing is they will send the order to the financial department, and the financial department also has another program written in PHP, which will read that order you put in, and then it will process the order. Process means two things. First of all, it will send your information to your credit card company and charge you money. And if it's good, they will send it to the shipping department for the shipping department to ship you the product. And this is the sequence of courses that take. Now, first of all, CIS 241 help you to design the look and feel of the website. That's what we call the interface. That means when you open up Amazon.com, you will see all those beautiful, beautiful pictures of books and merchandise. And that we would help you to design the websites, and that is in 241. And this is the what we call the user's interface. That's what you see in your web browsers, like Internet Explorer, Firefox, etc. Now, when you are ready to purchase something, of course, you click on the items, and then you click on the button in your shopping cart, whatever, to add to your shopping cart. And now that is where your JavaScript, which is running in your computer, in your Internet Explorer, because it's now, that is before it's sent. When you click on a button, of course, your computer, your Internet Explorer must have some kind of intelligence to know what you type in. And then also have some kind of intelligence so that it can take all those information, and then it will forward it to the server. And when those information, like how many books you purchase and what books you purchase, reaches the Amazon server, and then the PHP programmer in the server take over. And then it will store all those informations in the hard drive, and at the same time it will send it to the financial department, which is, of course, they have another server, and then the process your credit card information, and it's good. Then this PHP program and also will come back to the main server, and the main server will also send that purchase to another web server or another Amazon web server, which that will be inside the shipping department. And then our shipping people will take over, and they will look for your merchandise in those gigantic warehouses, put a label, address label, and send it to you. And that's how the internet works. And of course, you need to know some kind of a technology, and then that's what we are here. And then we want, that is what this curriculum is about. And then we have, of course, you have a certificate, which is for 1 year. And then what do you get when you kind of stay and then go for that 1 year? Now here, let me tell you that if you take the COC, and then after you're taking these 3 classes, you can just stand back and do some kind of reflection. You would kind of look, well, is this kind of field what I'm interested in? Or is this what I'm best in? You have to make 2 decisions. You make one decision. That means whether you want to continue this, or you can continue to other field, like networking, whatever, that the other instructors. You have to stand back and ask yourself 2 questions. Number 1 is, are you really good at this? Number 2 is, are you really interested in this? If the answer is yes, well, you can, of course, use that degree and then start looking for jobs, okay? And then, of course, you can continue for the certificate, which is 1 year, and then you have to take more courses. And then what are those? What more can you get when you go to that 1 year degree? Well, essentially, we will teach you Joomla. What is it? What is 244, 245, and 246? What does it have? What does it have to offer? More than the 3 courses in the COC. Well, well, we look at 242, all right? Now, that's what it is, okay? Joomla and SEO, and quickly I tell you what it is. Well, what's Joomla is we will teach you to generate, to develop not only just 1 or 2 web pages. We want to develop the entire websites. We have hundreds or even thousands of web pages. That's what CNN, Google is, or Amazon. They have 10 or 1,000 web pages. That means we are going to develop not just a comprehensive website, and this is what this technology is. And what is SEO? SEO is search engine optimization. That means we want to teach you how to generate websites that when somebody search for shopping, your websites will always come above Amazon. That means search engine organization. So you want to just come to me, and then of course I see that my time is up, but your time is not. You can always go in this program, and then you can spend your whole lifetime or career in this field. Okay, that's it.
Does anyone have any final questions for Louis?
Any questions here? Go ahead, sir. Yeah. Actually, the security is an interdepartmental discipline. Of course, Steve also they will talk about security. But then if you go into our highest degree, which is a technical arts degree, and then we will have courses to teach you to do secure programming. Quote unquote, 2 words, secure programming. Programming a website is not enough, absolutely not enough. You have to program a website that is secure, so that if you program a website like Bank of America, if it is not secure, it's totally useless. As a matter of fact, they will cause you, get the bank into trouble. So it must be secure. So secure is actually a built-in curriculum. But then you have to go to the 2 years degree because it is an advanced degree. In order to fight the hackers, you have to know more than the hackers. So you have to be better than the hackers. So you cannot do this just in the first quarter or first year. You have to go into the second year. Yeah.
Yeah. So as far as security goes, I'll be covering that in my presentation. So.
Yeah. Yes. Yes, sir.
I was just wondering what PHP stood for. I didn't see it up there.
Oh.
Is it an acronym?
Yeah, the PHP stands for
Personal.
homepage. Okay, so then many of these terms like Java or PHP, because all these are developed not by the company, but what we call open source. That means developed by hobbyists like me, and they are not hired by the company, so they can name all the technology anything they want to. So PHP is developed actually by a hobbyist, so that's why you don't have to pay for it. It's called a personal homepage. The reason they call it personal homepage is that he developed this language to develop his personal homepage. It's actually not developing it for commercial purpose. And then, so just like Mark Zuckerberg, who developed Facebook, he actually developed it so that he can communicate with his buddies in Harvard University. He never envisioned it to be a commercial endeavor. So that means he developed this language actually to develop his own personal web page. And then it worked so well that his buddies, of course, start using this PHP technology. And then it still become open source. That means you don't have to pay for it. And then of course he become famous. The person who developed PHP become famous. Of course, he make a lot of money by becoming famous. You don't have to be.
Thanks, Louis. Thanks, buddy.